For most of human history, a look at the night sky suggested a simple, overwhelming picture. The universe appeared as a chaotic spray of isolated stars, scattered across a featureless dark void. That assumption collapsed when astronomers began measuring the exact distances to millions of remote galaxies. They discovered that instead of a random distribution, the universe possesses organized geography. Our own Milky Way is caught in this current. We are flowing along invisible gravitational tributaries, pulled steadily toward a massive shared basin called Laniakea. Yet Laniakea is only a single local neighborhood. Zoom out further, and our entire basin shrinks into one tiny interception of an endlessly repeating, interconnected network known as the cosmic web. Every star, planet, and galaxy we can observe has a specific address dictated by this overarching arrangement of matter. This structure has four main features: massive galaxy clusters, the long filaments that link them, broad walls of matter, and terrifyingly sparse, empty voids. But the scale is difficult to comprehend. A single connecting filament can stretch so far that light itself needs hundreds of millions of years to travel from one end to the other. This creates a physical problem. Gravity is a slow, patient force. If the universe began perfectly smooth, there hasn't been enough time since the Big Bang for gravity to drag matter across these enormous distances. The web's existence suggests that the universe's starting conditions were uneven from the very beginning, providing a head start for gravity to begin its work. The layout of the modern cosmos started at a scale smaller than an atom. In its earliest moments, space held tiny, restless quantum fluctuations, microscopic variations. A fraction of a second later, an event of rapid expansion blew those microscopic ripples up to cosmic proportions, freezing density differences across the young universe. Dark matter gathered inside those variations first. Because it doesn't interact with light, it formed a framework long before the first stars ignited. Dark matter built the gravitational valleys that would guide gas and galaxies into place. The visible universe of stars and galaxies is a secondary layer, settling into a hidden foundation that was established billions of years ago. Now, ordinary gas and galaxies are continuously being pulled into that dark matter scaffolding by gravity. As gravity pulls material toward denser regions, it carves out vast bubbles of emptiness in space, causing isolated voids to grow wider and distinct. The displaced matter channels into the dense boundaries between these voids. Galaxies migrate along these cosmic highways, drifting like slow rivers across eons. Eventually, those filaments intersect. At these crossroads, gravity pulls thousands of galaxies into crowded swarms, where they merge to form massive clusters. The cosmic web maps a continuous migration, a record of matter flowing through space as gravity organizes the cosmos into its observed form. This entire structure is caught in a tug-of-war. Local gravity is fighting to pull matter together, while dark energy works to stretch space apart. Currently, dark energy is winning. It is driving an accelerated expansion of the universe, forcing the stage itself to widen at an ever-increasing rate. As the voids expand, the physical distance between filaments is growing faster than light can cross it. While gravity is strong enough to hold local galaxy clusters together, it cannot protect the immense bridges spanning the space between them. The overarching network of filaments is being dismantled by the very space it occupies. Billions of years from now, expansion will push distant filaments beyond our observable horizon. Their light will stretch out and fade, becoming unreachable. Future civilizations arising in that distant era will see only their immediate local cluster. They will find no evidence of a larger network, assuming they are alone in a dark, featureless expanse. We occupy a different reality. Today, we can still trace the ancient light and map the connections that bind the cosmos together. Humanity exists in a narrow, temporary window of cosmic history, the specific era where the universe has grown into its current structure but hasn't yet expanded enough to hide it.